Hey there, awesome physics students. Let's talk about the connection between momentum and force. And we'll just do this in one dimension. So if you recall, the net force is just what you get when you add up all the other forces. So imagine you have a couple of different forces, force 1, force 2, force 3, so on and so forth. Some are positive, some are negative. Again, we're working in one dimension. Well, at the end of that, once you add those up, you set that equal to mass times acceleration. But what is acceleration? Remember, acceleration is just the change in velocity over the time interval. Well, this part, if I take mass times velocity, that looks just like momentum. So let me take that mass in there because the mass of a particular object does not change when it's feeling forces. And so now this looks like the change in momentum over time, and that's exactly what that is. So this tells us that net force, force is the rate at which momentum changes. Okay, so that's very useful and interesting. I think we can see this with a realistic conceptual example here. Imagine you have a ball resting on a table, and what's happening is that the gravitational force is hitting this. You can imagine it's injecting, when it's hitting it and tapping it, and transferring a certain amount of momentum into that ball once every second. And then because it's resting on the table, it's also feeling a force, a tap up from the normal force at the same rate. And so the effect is that it's getting these injections of momentum, that is, momentum is entering to the ball from these forces at the same rate. And the effect is that the ball's momentum change is zero because it's feeling a negative momentum change and a positive momentum change from those two forces at the same time.